Hey, welcome back. You know, we're surrounded by text, like all the time. It's in our messages, our Google searches, our code. It pretty much runs our entire digital world. But what's really going on under the hood? Well, there are some pretty surprising and very strict rules. Today, we're going to decode them.
All right, so let me ask you something. What do a tweet, an emoji, and even a line of code, what could they possibly have in common? I mean, they look totally different, right? But to a computer, they are all basically the same thing. Any guesses?
Well, the answer is actually super simple. They are all strings. That's it. You can think of it as the universal name for any kind of text. And once you get this one concept, you're on your way to understanding how software deals with, well, pretty much everything you read and write.
Okay, so what is a string, really? Let's break down this fundamental building block of all the text you see on your screen.
You know, for such an important concept, the definition is pretty simple. A string is just a sequence of characters. That's it. It could be letters, numbers, symbols, spaces, even your favorite emoji. The key is that the computer treats that whole sequence as one single chunk of data. In a lot of programming languages, this is just called the str type.
And actually making one, it's super easy. In a language like Python, you just wrap your text in quotes. You can use single quotes, you can use double quotes. It really doesn't matter. To the computer, they both mean the exact same thing. You've just created a string.
All right, so we get what they are, but how do they work inside the machine? To really get a grip on this, we're going to use a great little analogy. Think of it as a row of numbered mailboxes. Just picture a string like a row of mailboxes, right? Each one's got a number on it. So for any word, every single letter gets its own little box, and that box has a unique address. This is how a computer keeps track of where every single character is supposed to be. And right here, this is probably the most important rule you need to know about strings. Take a look at those numbers on the mailboxes. See something kind of weird? Yeah, they don't start at 1. They start at 0. This is called zero-based indexing, and it's a huge deal in programming. The first letter is at index 0, the second is at index 1, and so on. And that right there, that numbered structure, is why this is so powerful. Because every character has an address. We can tell the computer to go grab any piece of the string we want, and this cool operation is called slicing.
Okay, let's see how this works for real. Say we've got the French word vacances. Inside the computer, each of those letters has its own mailbox, its own index number, all the way from 0 to 7. So now we can give the computer a command like this. The square brackets basically mean, hey, I want to grab a piece of this string. The 4 says start at box number 4, and the colon just means and go all the way to the end.
And boom, just like that, we get back senses. We've just sliced off the end of the word. You can see how this would be super handy for pulling apart dates or emails or anything with a structure. Okay, but this brings up a really interesting question. If we can read any part of it so easily, can we change it too? What if we wanted to swap out just one of those letters?
And the answer, maybe surprisingly, is a big no. This is the second huge rule you gotta know. Strings are immutable. That's just a fancy way of saying they're unchangeable. See, with something like a list, you can totally swap out an item, no problem. But if you try that with a string, if you try to change just one letter, you get an error. Once a string is made, it's locked in.
So how do you get around that? If you can't change it, what do? Well, you don't even try. Instead, you just build a brand new one. You take the new letter you want, you slice off the part of the old string you want to keep, and you just stick them together to make something totally new. The original is never touched.
Okay, so let's recap the rules really quick. Strings are ordered, they start counting from 0, and you can't change them. But why does any of this technical stuff matter? Well, this is where it gets really powerful, because these simple rules let us turn messy, raw text into actual, useful information. Yeah, this quote really nails it. When you get good at handling strings, you can start making sense of raw data. You can automate tedious tasks, and you can build things that communicate way more effectively. Honestly, it's one of the first things you need to master if you're working with data or code. Let's look at a perfect real-world example. It's called parsing. Imagine you've got a sensor, and it sends back this little text message. To the computer, temp equals 24.5 is just gibberish, right? It's just a string of characters. But with what we now know, we can tell it to find that equal sign, slice out everything after it, and boom, turn it into a number. We've just turned meaningless text into real information.
And here's the best part. You don't have to write code to do all this from scratch every single time. Modern languages have these built-in tools called methods, and they're basically shortcuts for all the common things you'd want to do with a string.
Seriously, these methods are like having superpowers for text. With just one command, you solve these common problems instantly. Need to make everything uppercase? Dot upper. Bam! Need to blow up a sentence into a list of words? Dot split. Done. These things are huge time savers.
And get this, we're not just talking about A through Z here. Thanks to this global standard called Unicode, modern strings can handle over 140,000 different characters. That means you can have characters from pretty much any written language on Earth, plus all those scientific symbols and, yes, every single emoji on your phone. All right, so let's just quickly pull it all together. What did we learn? 1. Strings are just ordered sequences of characters. 2. They're built on that zero-based indexing. Always remember the mailboxes start at 0. 3. They're immutable, which means you can't change them, you just make new ones. And 4. They come with this awesome toolkit of methods to get stuff done.
At the end of the day, the biggest thing to remember is this. Text is data. It's flowing all around us in every single app we use. It is the raw material of our digital world. So now that you know the fundamental rules that run it, the real question is, what are you going to build with it?